Hi, welcome again to our third part of Gmsh tutorials by QuickerSim team. As you remember, you can use your Gmsh meshes in QuickerSim CFD toolbox for MATLAB, and the free version of our software you can download immediately from www.QuickerSim.com. In the third tutorial, we are going to make a step towards more advanced features like writing scripts and defining size fields, which give you very detailed control of your mesh resolution. So at the beginning we are going to talk about introduction to Gmsh scripts and then about size fields. Alright. I will start this presentation from the L-shaped geometry that we have created in the first tutorial. So I would open my GeoFire. If you've got your own GeoFire, you can open your own. If you haven't got it, I will show you where you can get it from. Alright, so I'm opening the file. I've got it right here, and if you haven't written that in during your first tutorial, you can always go to www.QuickerSim.com and then in this CFD toolbox for MATLAB, go to Tutorial Center, and here in Geometry and Mesh you will be able to find help for our Gmsh tutorial. Alright, so we've got the same geometry again. What we could do is, we already know we can generate the mesh 1D, 2D, and we get it. But what I want to show you is I want to open the geometry. I want to open the GeoFire, and I want to show you how to define scripts in Gmsh. Let me only make the font a bit bigger, and I would like you to open the file and have a look at that, because everything that you normally click on in the graphical user interface in Gmsh is translated by Gmsh automatically into a script. So once you create the geometrical file, all the commands that create these points, lines, surfaces, physical groups, and rotations, translations, symmetries, whatever you define, is written here in the script. The good point is that you can parameterize it. If you need to know what the commands mean, you can always go to gmsh.info, and I recommend opening documentation, then reference manual, and if you go to, for example, geometry commands, then you can have a look at that point expression. Then you need to specify 3 coordinates, and then you specify the size of the element. Everything is described very carefully in these explanations, so whatever you need later on, like B-splines, circles, lines, surfaces, and so on, and geometrical transformations like rotate, symmetry, and things like that, just please go to this documentation. We will not go through all these commands because it doesn't make sense. We are going to show you that you can do it and what the philosophy is, and you will be able to find appropriate functions that you need. Alright, so let's try to change something in the script. Let's imagine, I have already told you that the last parameter in the point command is like x, y, z. This is pretty clear. but later on you've got the size of the elements. So let's try to define h1. Let's define it as 1/10, and we would like to specify that we would like to have at point 1 and maybe also at point 3 we would like to have elements of size h1 at point 1, and we would like to have elements that are twice bigger at point 3, so we are writing 2 times h1. Gmsh scripts always accept like algebraic operations, so you can define formulas in a usual manner, like in every different programming language. Alright, what I need to do right now is I need to file open recent. So I need to open the script file once again, and right now if I select 1D and 2D, just see what happened. I've got 10 times small elements close to that corner where point 1 is located, and I've got bigger elements here, twice bigger, and more or less everything else is unchanged when it comes to the size of the elements at the points. If I right now go to Tools, Options, Mesh and the General, and I decrease my element size factor, as I said previously, this is just a scaling factor. So you will see the element sizes which are not 1/10 but even smaller here, because this element size factor is just a scaling factor. Alright, this is one of the ways how you can use scripts. But probably an even much more interesting thing is to parameterize your geometry. Let's assume that we want to have edge shapes of different length and different height. So I would add one additional parameter like L. Let's say it should be 8. Let's check with Tools, Options, Geometry, Visibility, Point Labels, and let's select Elementary Tags. I can see right now that I've got point 2 and 3. These are my points that define length in the x direction. So I would like to change this that coordinate of 5 to L, and the same with 3. But of course I don't want to change the width of my geometry, so I also need to parameterize point 4, which would be 1 less than L, and point 5, which is also L minus 1. And we would do the same. We want to have different height, so point 3 should be not 5 but H, capital H, and the same with point 4, also capital H. By doing this, I have parameterized the whole geometry with 2 parameters, or sorry, I haven't. Let's say H equals 4, and open recent L-shaped geo, and right now you can see beautifully it's automatically changed geometry. Of course you can imagine that you can parameterize your geometry in this manner and then generate mesh in Gmsh automatically and use this parameterization, for example, for optimization. You can run this for example, with MATLAB optimization toolbox and solve the fluid flow or heat transfer problem in QuickerSim CFD toolbox for MATLAB, or in every other solver you can where you can use your meshes. All right, let's try to generate the mesh once again. Of course, our specification of element sizes is retained, so nothing has changed here. In many situations, it is important that we have a particular number of subdivisions on edges. So we would like to have, for example, 25 divisions of that line, and we would like to refine our geometry to that edge. So to define divisions on lines, we have this mesh module, then define, and we do it by selecting transfinite line, and we're telling we would like to have 25 points, and we've got either progression or bump. Progression means that we have refinement either to one side or the other side of the line. Bump means that we will have bump, so refinement in the center, or coarsening in the center, which basically means refining to both ends. Let's select progression, and you never know whether you should have parameter smaller than 1 or bigger than 1. You probably need to check this. All right, let's try with 2, 1D, 2D. True, that's in many situations you need to load it again, and 1, 2, sorry, this is my mistake. What you need to do is you need to select transfinite line 25, 2, and then you need to select the line and hit E, because otherwise it won't work, because I haven't selected the line. That was my mistake. So once again, 1D, 2D, and you can see that it's really not what you'd like to have. You've got a very dense mesh here, because what it did, it created every element twice longer than the previous one, so you've got plenty of extremely small elements here close to that corner. We can edit it in our script, because if you're using a smart text editor, like for example Notepad++, it is able to detect that the GeoFire has been changed, and you can also see how the script is created, because it right now says transfinite line 25 divisions using progression 2. We want to refine to the other side, so we don't want to have 0.2, rather we would like to have something like every element should be by 5% bigger than the previous one, but I want to refine in the other direction, so let's take the inverse of that. Right now I need to reload the GeoFire 1D, 2D, and right now you can see that you've got a pretty nice pretty nice refinement to this end, and the bigger elements in the other one. Of course, if you change it to, for example, 1.1, this effect will be even stronger. Let's open recent 1D, 2D, and you see a very nice refinement to this edge. Right now I'm going to talk about size fields. In many situations, if whatever you want to solve, if you want to solve structural dynamics, you might have very big problems at sharp corners, because cracks and things like that can be generated under tension. The same happens in solving fluid flows. If you deal with turbulence and you've got shear layers, strong velocity gradients and things like that, you'd like to refine your mesh somewhere inside of the region, somewhere inside of the domain of the fluid domain or the solid domain. What you can do is you can define a size field. Let's imagine, maybe this will not be a very wise example, but let's imagine that that something extremely interesting can happen in this region of the domain. So we would like to have really small elements here, so we would like to have big mesh resolution, but this means it is where you can't choose size of the elements at the point or number of subdivisions on the line, because you want to refine your mesh somewhere inside of the domain. So size fields is the thing that you need. Again, under mesh module, you've got define size fields, and let's create a new size field. Basically, size field is something that tells to the mesh generator how big elements you want to have in a particular subregion. All right, let's select new, and you've got many different size fields. We would choose, for example, cylinder. Just remember, I've got height or width of this geometry 1, so I would select radius like 0.25, and right now I need to specify what kind of element size I would like to have inside of my cylinder and outside. Outside I would like to have 1, but inside I want to have something really fine, like 0.05, and I need to specify the unit vector along the x-axis. Let's say it's just 1. Along the y-axis it's 0, along the z-axis it's also 0 in my case. And where is the center point? I would open Tools, Options, General, Axis, simple axis, because I want to display the coordinates, I don't remember them. Alright, let's assume we would like to have the center here. So like 5, Y center is just half, and Z center is 0, and set as background field, yes, we want to have it, apply, and we've got cylinder, and we can visualize this, create new view, and we can't see the colors because we have displayed the mesh. So we go to options, to tools, options, mesh, visibility, and just toggle off the surface, the visibility of surface faces. Alright, and by doing this we have visualized our newly created size field. What you can see is you've got red everywhere, so you would like to have size elements of size 1 here, but here in this region, which extends by 1 in the x direction, from 5 to 4 and from 5 to 6, you would like to have really small elements of the size 500. Alright, so just see what happens if we click on 1D and 2D right now. It's nice to toggle the visibility of surface faces once again, and that's it. Maybe it's not very smooth, but it definitely works. You can also define, yes, I will reload the script and see that what we have done is we have created the filled cylinder with a specified radius and certain parameters inside and outside. So maybe let's change it to a small value. 0.2 is something which I would like to have outside of my cylinder. I will reload it, and also right now our mesh looks much better. Of course, you can imagine that you can do the same both with scripting and manipulating by size fields. You can very easily define the mesh resolution with this pretty advanced technique, and I encourage you to try with that, because mainly for the computational fluid dynamics simulations, it is extremely important to refine your mesh in places where many flow features exist and where you have very complex physics. I hope these 3 tutorials on Gmsh helped you to get very quick and smooth start into this software, this preprocessor and mesh generator, and you're encouraged to use QuickerSim CFD toolbox for MATLAB, but you are also encouraged to dig into Gmsh because it has got plenty of extremely nice important features, and you can do much more with Gmsh that we have shown you, and simply go to documentation and try to find whatever you need, because there is much more than only this short 3 movies introduction to Gmsh. It was a pleasure for me, and hope you have enjoyed. See you then in the CFD world.